Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll do the integration of dx divided by e to the power of 3x minus e to the power of x. If I look at my integral, I know that I have e to the power ex in common in my denominator. So let's factor out e to the power of ex. So it becomes dx divided by e to the power of x times e to the power of 2x minus 1. Now, looking at it, I know that I have to do integration by partial fraction because I have a multiplication in my denominator, multiplication of two variables. And I know that I have to let u equal to e to the power of x. But if I take u is equal e to the power of ex, my du would be equal ex dx. But in my numerator here, I don't have ex dx, I have only dx. So let's add the ex to my numerator and divide by ex my denominator. This way I won't change anything. So my integral become ex dx divided by ex. So this is the ex that I added, I divided by it. And I used to have ex times e to the power of 2x minus 1. Now if I replace u by ex, I can replace du by ex dx, which is exactly what I have in my numerator. So my integral become du over u times u is u square times u square minus 1. But if I look my denominator, u square minus 1 is like a square minus b square, which is equal a minus b times a plus b. So my integral become du divided by u square times u minus 1 times u plus 1. And now, integration by partial fraction become very easy for me. My integral here become, like if I take du or 1, not du, 1 divided by u square u minus 1 times u plus 1. U minus 1 times u plus 1 is equal a divided by u plus b divided by u square plus c divided by u minus 1 plus d divided by u minus plus 1. Now, if you want to know how did I come to that formula, I have a video by the name Integration by Partial Fraction. I will put the link in the description of that video. If you watch that video, you would understand how come I divided it that way. So now let's take the right hand side of my equality, which is a divided by u plus b divided by u, the right hand side of the equality, and I will do a common denominator on my right hand side, which is this. I have to do a common denominator on this one. So the common denominator will be u square times u minus 1 times u plus 1. Yeah? So if I divide u square, u minus 1, u plus 1 by the u that is here, I would have the a multiplied by u minus 1 times u plus 1. And if I divide my denominator by u square, I will have the b is multiplied by u minus 1 times u plus 1. And if I have my denominator divided by u minus 1, I have my c is multiplied by u square times u plus 1. And my d would be multiplied by u square times u minus 1. And all that is equal to 1 divided by u square u minus 1 u square times u minus 1 times u plus 1. Anyway, because I would have the same denominator in the left hand side of the equation and the right hand side of the equation. So my denominator here is exactly my denominator here, and it's exactly my That is the denominator here. So now I can afford to take out the denominator. And at the same time, I want to take out all the parentheses by developing the multiplication of the parentheses. So this becomes a times u times u square minus 1, because u minus 1 times u plus 1 is u square minus 1, plus b times u square minus 1, plus c u to the power of 3 plus c u to the power of 2 plus d u to the power of 3 minus d u to the power of 2 equal to 1. So let's develop those parentheses that is here. It becomes au to the power of 3 minus au plus bu to the power of 2 minus b plus cu to the power of 3 plus cu to the power of 2 plus du to the power of 3 minus du to the power of 2 equal to 1. Now let's factor out the one with the same variable. Let's highlight them. I have a to the power of 3, c to the power of 3, and d to the power of 3. So now I can put a plus c plus d multiplied by u to the power of 3. And let's take another color here and highlight to the power of 2. So I have b u2, and then I have c u2 minus d u2. So plus b plus c minus d, all that to the power u2. And then I only have minus a to the power of u, and I only have minus b here equal to 1. So this is minus b, and this is my minus a to the power of t. Because on the right hand side of the equation I don't have u to the power of 3 and u to the power of 2, neither do I have u to the power of 1. So anything with u to the power of 3, u to the power of 2, and u to the power of 1 on the left hand side would be equal to 0. So I can say a plus c plus d is equal to 0, and then b plus c minus d equal to 0, and minus a equal to 0, and minus b equal to 1, because the 1 does not have u as a variable, and only b does not have u as a variable. That's why it's equal. So now from this I can conclude that a is equal to 0 and b is equal to minus 1. Perfect. I'm still missing a and b. C and d I'm missing. So now here I will replace a by its value, which is 0. C plus d is equal to 0. That means my c is equal to minus d. And from that equation here, if I replace c by minus d and b by minus 1, I will have minus 1 minus d equal to 0. So minus 2d equal to 1, and my d is equal minus 1/2. And if I have my d is equal minus 1/2, I can take, let's highlight it so you can see it. I can take this and replace d by minus 1/2 and calculate my c. So c minus 1/2 equal to 0, then c is equal 1/2. Because c plus d is equal to 0, so I put c minus 1/2 equal to 0. So now I have all my variable. So I go back here. I'm coming back to this here, and I will replace a, b, c, and d by their values. So my integral will become integral of 0, because remember, I want to have the integral of this, so I will do the integral of that. So become a is equal to 0. 0 divided by u du plus the b is equal to minus 1, so I will put minus 1, not plus. I will put minus integral of 1 divided by u squared du, plus my c is equal to 1/2, so I can take the 1/2 outside my integral, become 1 divided by u minus 1, and my d is equal minus 1/2, so I will put minus 1/2 outside my integral, and it will become 1 divided by u plus 1 du. Perfect. So I take the first integral here. I will take that integral here. 0 times du is 0, divided by u is 0, and the integral of 0 is 0. So that does not count. I cross it out. And the second integral, minus 1 over u square, I can write it u to the power minus 2 du. And that is equal minus, that is here, I have to put it here, u minus 1 divided by minus 1 plus c. Yeah? So it become minus times minus is equal to plus, so it become 1 over u. So that integral here, I did not mean to delete it. I meant to take this. That integral here is equal to 1 minus u, 1 divided by u, or u to the power of minus 1. Or u to the power minus 1 plus c. So now I will take this integral that is here. That integral 1 divided by u minus 1 is equal, the 1/2 I keep it because it's outside the integral, plus 1/2 ln of u minus 1 minus 1/2 ln of u plus 1. So let's move it a little bit here. Minus 1/2 of ln u plus 1, and all that plus c. I will add the plus c at the end. So as we said, this is equal to 0, and this is equal to u minus 1, but I know u is equal e to the power of x. So it become e to the power of minus x, plus I can put 1/2 ln of u minus 1 minus ln of u plus 1. So it's equal e to the power minus x plus 1/2. And here I want to use the logarithmic rule. Ln u minus 1 minus ln u plus 1 is equal to ln u minus 1 divided by u plus 1 plus c. And that would be the solution of that integral. I hope you like my video. If you are enjoying my videos, please subscribe to my channel. That would help me continue doing whatever I'm doing, and it will help you pass the course actually. And if you put a like, I would really appreciate it. Thank you for listening.